Hello everyone, my name is Tai Chiwei and I'm from class DAM 2A. I'm in group 5 and now we are going to present about you the application of integration. Thank you.
Hello, my name is Rishikeshan and my registration number is 24DAM22F2009.
My name is Modahan and I'm from class DAM 2A. My matric number is 24 DAM 22F2003. I am from group 5 and today I want to explain about the basic method of integration and definition of integration. Introduction of the integration. Integration is a method of adding or summing up to find the whole part. It is a reverse process of differentiation where we reduce the functions into a part, and integration is basically used to find the areas of two-dimensional region and computing volumes of three-dimensional object. Therefore, finding the integral of function with respect x means finding the area of the x-axis from the curve. Secondly, I want to explain about the basic method of integration. Method of integration include different methods of solving complex and simple problems of integration in calculus. To apply a specific method of integration, first we need to identify the type of integral involved and then apply the most suitable method of integration to solve it. After that, we will explore different methods of integration such as integration by parts, substitution method, and method of integration using partial fraction and reverse chain rule among other. We will demonstrate a question to understand the application of this method of integration.
Integration by substitution. Integration by substitution is also known as U substitution. Is a powerful technique used to simplify the integration process by substituting variables. It helps us to solve complex integral effectively. So the next one will be application of integration. Integration has numerous real-world applications, including finding area of irregular shape, calculating volume of solid, modeling physics phenomena, and solving differential equation.
And this is the given question and solution. So now I'm going to demonstrate about the question of it. So this question is talking about we need to find the volume of the area that is formed of the region is bounded by the curve is the y square equals to 4x and the y square equals to negative x plus 8. You can see it from here, and this graph we get it from the graphic calculator is in website. So as you can see here, we listed out the two equation. If we want, as you can see that there's two intersection point between these two curve. So first thing that we need to do is to find the 2 point of it. So as you can see that I already draw it out to present that this is the part that we need to integrate to find that volume. So that the first thing that we need to do is that we need to assemble it all the things beside from x to the left hand side. So as you can see, this is just only 4, so when you move it to the equal, you can just get a quarter of y square, and this one is the y square negative minus 8, but we still have a negative x, so if we draw it, because actually this is negative 1 times x, so we move it through the equal, we can just directly switch this two thing of it. After that, we can combine these two things to find the y. Because we need to get y is because that when we integrate is using the y-axis, so we need to get the y value. So that after we put in here, we just set the right hand side is just equals to 0 only. So we just move everything to the left hand side. After that, as you can see that this is kind of like quadratic equation form, so we use this to find the y. After we substitute all the value in here, we can get the y is equal to 4 square root by 10 and it's divided by 5, and the other point is negative of it. After that, after we get these 2 points, now we can integrate this curve, these two curves, to define the volume of it. And the last part is that we can cancel out at this point, because after we cancel out, we will just left this part, so we can get the volume that the question wants us to find. So the formula that we're using is the pi integrate by the limits is a to b and is the square of the function that we need to integrate. And because the value that we're using is y, so we will use the dy. And like we were doing the purple curve first, so we just put in the equation for the purple curve, because we are doing the differentiate the equation by using the value y. So actually this is using the x square, because the x is equal to this equation, so it's actually need to square it out. So after we square, we can get the 64 minus 16y squared plus y power 4. After we integrated it, we can get the 64y minus 16y cubed divided by 3 and y power 5 divided by 5. And the integration is working like kind of inverse of the differentiation, because when we differentiate it, is that we will times the constant with the power that before it's minus 1. So at the integration that is inverted it, so we were doing like we add on the variable, like when it's 64 is a constant, right? So we add on a variable onto it. The variable now is power of 1. So we will, because the differentiation is times, right? So because when it's inverted, so it will become divided by it. So because the y is power of 1, so if we divide by 1, it's also still the same. But when we go to the next one, is the next term is that is y power of 3, because before integration is 2. After we plus it 1 is 3, so we're going to divide by 3. Is same goes as the y power 4. After we add on 1 onto the power, we're gonna get y power 5 and divide by the power is also the 5. So the next step is that we substitute the limitation for the integration. Like the upper one, after we sub the upper one, we need to minus the lower limit as shown as here. After that, we can get the value, the volume for the purple curve is 192.5633 pi unit cube. And the next step is same goes to the other curve. Like this green curve is a quarter of y squared. You also need to square it out, like become 4. After we square, it will become 16. So we can get this one. We also do the same thing like before, and we can get the volume for the green curve is 2.5905 pi unit cube. That is from the y-axis for these two curves of the volume. After that, if you want to find the boundary region, like as shown as here, so we need to minus the purple part. We need to use the purple part to minus the green part, and then we can get the red part that we need. So we are using the 192.5633 pi minus 2.5905 pi, and then we can get a 189.9728 pi unit cube. And here, that's shown here is the 3D model for the equation that we calculated just now. And this is the volume like for it. As you can see, this is y and this is x. Okay, thank you. Now let's pass it to Rishi.
And then the conclusion would be integration is the method we have to figuring the cumulative effect of forces that undergo variation as they act on a body while it is in motion. Integral enable us to define the cumulative effect of kinetic energy. The application of integration in real life is based upon the industry type where this calculus is used. So that's all from us. Thank you.